Insulation system. Now, this is something which is very interesting and is becoming a part and parcel of the building construction concept, which earlier were not very common in the country, but now with the support of the Energy Conservation Building Code and the arousal knowledge about the energy and the shortage of energy, which makes it very, very important, and especially if it is a steel building, because steel building is something where you get a lot of extra heat coming in because of the good conduction of the material, because of which insulation again becomes more of a necessity. Now, if you see the construction which is now going and picking up, especially if you compare northern India with a huge construction in Gurgaon areas where we have all the latest architect buildings coming up with stone cladding, with aluminium cladding. Now, if you minutely see, this insulation is becoming a reality now. Now, in this presentation, I'll quickly run through, because of the paucity of time, about the actual application of insulation and some of the pictorials which will actually make you understand where all in a roof and a building or on a wall in a building where you can have the insulation and what can be the effectivity. Now, basically in India, where we have summer as one of the predominant, because it is even places like Manali, Shimla or Srinagar touching ambient temperature around 30-35 degrees centigrade. The inside working conditions also require a lot of changes, and we find that mostly in most of the cases the roof is where you actually have most of the heat incidence, and now especially in a condition when your operating condition is also heated up and also with a huge humidity coming up, like in Delhi now we are having ambient temperature not much, but with the humidity coming up the entire working becomes oppressive. Now insulation plays a very major role in trying to make this system quite attractive. Now if you see this particular slide, typically because of the construction methodology, it's a RCC roof, it's a metallic roof, and then we have the black body waterproofing on top of it. Whenever you have an actual ambient of 40 degrees, the temperature on top of the construction system touches almost 10 to 15 degrees on the higher side. So this is very, very important. And when you are trying to maintain a temperature of air conditioning 22 or non-air conditioning 32 degrees centigrade, this delta T, as long as this gap is more, the conduction of the heat to come inside will be much higher and higher. Another important factor is that because of this temperature gradient, that is not the ambient, the actual which is going to come on top of your waterproofing, on top of your tiling, where most of the buildings of RCC they will have a tiling system, or the steel building which will have a metal sheet on top. You will have to select the insulation metal which is actually suitable for such high temperature. Many a times we try to have the architecture copied from the US or copied from the Europe, but you have to keep it in mind. The ambient conditions in our country is more predominant to the summer conditions than the winter conditions. So the material which you are selecting need to have a protective cover of operational suitability, nothing less than 70 to 80 degrees centigrade. This is the most important. So our attempt is always either to make inside cool or during winter to make inside warm. Now, what happens when the heat comes on the roof? There is a temperature in the initial part of the day, the initial temperature inside will lower. But because of the radiative impact, the roof gets heated up and the heat comes inside. So that is where we try to make as a barrier. Now, with all these things, even human beings, we say, are always into some thermal stress. We start in the morning, typical of day to day. We start in the morning with an ambient temperature inside, maybe around 30 degrees centigrade. But as the day progresses, what happens is that even your ambient touches 40 degrees, sometimes inside the floor temperature touches something on 40 to 43 degrees centigrade. Why? Because the humidity impact, the heat is not able to radiate outside, it is rather radiated inside. So there we come to actual applications of the insulation. Now if you see, another important factor is air conditioning buildings. Now air conditioning buildings is that where you require temperature maintenance inside. Now in an air conditioning temperature where you have 22 degrees centigrade or you have 25-26 degrees centigrade with ambient outside more than 40 degrees centigrade, radiated heat coming inside, your compressor running time increases. Why? Because your compressor is trying to cool down the atmosphere inside, but heat is coming from the roof and the wall. So your running time of the compressor increases, and that is where you have a lot of increased energy consumption. We have seen by statistical figures that between an insulated and uninsulated building, the consumption of energy varies something from 30-35%, even to as high as 40%. Now coming to winter conditions also. Now winter conditions is not that severe as compared to the other countries. If you see US and Europe, you will find very thick walls because summer conditions condition or the hot condition attacks the roof. But if it is a cold climate, it remains at the ground level. That's why in the US and the Europe, where you have more lower ambient condition, the walls has to be very nicely insulated. But typically we have seen in Delhi also, when we have actually the ambient temperature of 3 to 4 degrees, maybe for 15 days, and outside higher ambient is not beyond 12 degrees centigrade, and that temperature persisting from 4 o'clock in the evening to next day morning, maybe around 10 o'clock, wall insulation also becomes important. So we see in our country also getting more attraction to the wall insulation concept. So we say the building is like an envelope. It has got a roof, it has got a wall, and both needs to be insulated to stop the heat and cold ingresses. Now coming into the actual requirements in a building construction, I will just cover up two main areas. One is the RCC construction and one is the metal sheet construction. Because this is a exhibition, it's a seminar which is concentrating on the steel construction, and as we have heard from various speakers that pre-engineered building is going to be one of the most challenging and one of the most common method of building construction. Already constructions have been done at airports. We are having construction even in residential houses. Even you will be surprised to know that in Shillong, 10 years back, the Northeast Council headquarter building, which was ground plus 3 floors, was made of pre-engineered steel building. So because of the fast construction, because the less time available, steel is coming up. Now along with steel, if you don't have an insulation, then you're going to have a lot of energy problems. Now what are the methods of doing the insulation system? That is where we are actually insulated. We are actually interested to know how we are going to insulate a building. Now insulation can be either below the roof from inner side, it can be possible to do it from outside, depending on construction, or even the roof material or the wall material itself can be selected in such a way that it can act as a finishing material, it can act as insulation. That is the sandwich system, which is very commonly picking up. Now if you see the underdeck insulation, this is exactly the pictorial how it looks like. You have the RCC roof and just below it you put the underdeck insulation. It is the most inexpensive way of doing the insulation. But keep it in mind, whenever you have insulation, it has to be snug fit. Just take an example, in peak winter, you are wearing a sweater and also you are wearing a woolly coat, which is more effective. It is the woolly coat which is more effective because it is snug fit to the body. It is not leaving any gap in between. So the heat, the cold is not able to attack the body. The same thing here. If you are leaving an air gap in between, mind you during winters, if the moisture goes inside, you can have condensation problem. So insulation has to be snug fit. There are various methods to make it snug fit. You can have a framework, it can be a wooden, it can be a GI channel framework. Put the insulation snug fit, then you can have a false ceiling. Or it can be a board which can be directly screwed down like an E-board or a gypsum board. So most common method is this. This is a pictorial method of one of the fibrous insulation material being shown here, the yellow color material which is coming up and then finally we are covering it. This is exactly what is done for the airports, what is done for the stadiums, whereby you have got a metal mesh fixed to the pre-engineered building or any steel building. You create a metal mesh bed, on top of it you put the insulation, then the metal sheet is put on top. It is not that you put the metal sheet, have a scaffolding and keep on fixing up the insulation. But this is exactly what you do from down below, the metal mesh, which is welded, fixed to the steel structure, and then you have the insulation. Another method coming to the wall insulation. Again, wall insulation can be outside, it can be from inside. If it is from inside and if you are actually doing a cavity wall insulation, again the requirement is that it has to be snug fit. Air is also acting as an insulation, but with passage of time, the air also gets heated up. And if you have got pores, you have got pockets into it, the heat may go inside also. So we said that insulation, if you at all you have to give a air gap between the insulation and the outer finish. But insulation needs to be mechanically fastened to the wall system. So this is one of the most common methods of doing a cavity wall insulation, where you have the main wall and the secondary wall in between you have the insulation system. And as this slide shows that as it rises now, insulation, why it needs to be mechanically fastened? Because it can sag down. If it is a fibrous insulation material, if you don't mechanically fasten it with the passage of time, it will come down. But definitely with rigid material, this is not required. This is just for fibrous material. And then this slide shows that after you put the insulation, and then outside you can have an aerated block, you can have a brick wall, just as a protective layer. This is one of the most common method in most of the sites in India. You will find that one brick wall coming up another. Second is that we also have a lot of aluminium paneling in the country. We have, because of the architectural finish we want to give. Now aluminium absorbs the heat, and if you actually keep a air gap in between, it will slowly, gradually also heat up the concrete or the brick wall, which will have the conduction impact if the building is air conditioned inside. Now most of these aluminum panel buildings are air conditioned. So this is the most common method. When you have your framework to hold the aluminum or the stone wall which is coming up, in between you fix up the insulation, very conveniently, very easy, and then you have your cladding. This is exactly the slide. So one side you show the yellow color insulation being fixed, and then other side is the aluminum cladding which is coming up. This is another building on which the insulation is being fixed up gradually, and this is the stone cladding which you can see. So you have the insulation, you find the air gap, and then the stone cladding comes up. This is the front view of that same building. So very conveniently this can be fixed up. Why the time will be not required much? Because the scaffolding which is being used for putting the stone cladding, the same scaffolding, the same person can do the fixing of the insulation and gradually move into the stone cladding fix system. So it becomes a very fast application. Another method which is going to be, we feel, one of the most success for doing the wall insulation is something called ETICS, that is external thermal insulation system. Now till now whatever slides I've shown you are basically with the fibrous insulation system, which is non-combustible water repellent grade. But if you are looking for buildings, especially residential buildings or commercial buildings where you have got a plaster finish and you are not looking for any external cladding like a stone or aluminium, most inexpensive, then you have got something called ETICS system. Now this ETICS system is basically fixing the insulation with a special adhesive, rigid type, directly onto the wall, and then after that you have your insulation system. In fact, China is one of the countries who has practiced this ETICS system very, very successfully with polyurethane foam. They have started with expanded polystyrene foam, extruded polystyrene foam, and gradually now they are falling mostly polyurethane foam insulation. So this ETICS system, I just quickly take you around a direct demonstration how easily this system can be done. This is the bare wall after it's been plastered, and then you take up the insulation slabs, mostly polyurethane. You fix an adhesive over a primer, and then after that you take the slab and directly can fix it onto the wall. So onto the plastered wall, this insulation slab can be fixed up very conveniently with minimum amount of labor. And in this way you can keep on fixing up the various slabs. And after you have fixed up the slabs, this adhesive is so strong that within 2 hours, even if you try to take it out or somebody stands on top of it, it will not be coming out. And then after that you start plastering. It's a polymerized plaster. You just take the plaster in 12 millimeters in 2 layers or 12 mm thickness total and put on top of the insulation directly, and it will get adhered. And in order to have a reinforcement, you can put in between the 2 layers and finally the building is over. The advantage is that you are stopping the heat right at the source. If you are allowing the wall to get heated up and then putting an insulation, then what happens is that insulation will have some sort of thermal stress. But if you have done it right on the outside, then what happens is that the building mother wall never gets heated up. The life of the wall also increases. So this is one of the most common methods. It is already picking up in the country. Even this is possible for existing buildings. Existing buildings can also be insulated. And the material which is used when you are selecting, please ensure that the temperature condition of the material, that it should be able to withstand nothing less than 75 to 80 degrees centigrade. Why? Because in a high ambient condition in India, when your ambient touches 40-45, with continuous exposure on the cladding outside the plaster, the temperature will be 10 to 15 degrees more. A most common example, we do tiling with a mortar on top of a building. After 4 or 5 years, it starts coming out. This is the reason. The tile gets heated up 45-50 degrees. It cannot withstand. It gets delaminated from the mortar. That is the reason why polystyrene foams are not much successful in India as compared to polyurethane. Because polystyrene foams have a temperature rating of around 65 degrees centigrade or maximum 70, whereas urethane foams can go up to 110 degrees centigrade. Partition wall is also very, very important because it will act not only as an insulation to segregate from the outside, but also will act as an acoustical wall. The most simple method, you have the dry wall system, a framework insulation, and both sides you can have a gypsum finish or you can have a keyboard finish. Another system is also insulation over false ceiling. Now this is an outdated concept because the false ceiling, when the insulation is put on top of it, there is a weight attached to it, it may fall down. A right example is right on top of this room only. You can see the insulation is hanging out. So false ceiling is a concept which is used to reduce the air conditioned area. But after some time, this is what exactly happens because of poor maintenance. So false ceiling is over insulation is not what is recommended in the modern architecture building construction. Like we showed you about the wall insulation from outside. Same thing, overdeck insulation is also possible over the roof. That is again attempting to stop the heat right at the source, not allowing your mother slab to get heated up. Now this is also possible with retain type of insulation material very, very conveniently. In fact, the oldest shopping mall in Delhi, that is the Ansal Plaza, has got an overdeck insulation. And if you go to the top floor of the building, where the Jammu and Kashmir Bank is there, the Bank of Punjab is there, you will find, even though there is a lot of skylights on top, but you will not feel the pinching heat there. Because it is sprayed insulation on top of the roof before doing the waterproofing, the mud slab will never get heated up. And the air conditioning impact is tremendous inside. So this is about the overdeck insulation. It's a one small pictorial example showing that you have the RCC like with the underdeck, you are doing it from top of it. Or you can spray it also, you can spray the insulation. If you are doing a spray insulation, the advantage is that you can spray thousands and thousands square meters. Suppose you are having a 10,000 square meter roof, you can spray, apply 10,000 square meters and it will be absolutely jointless. So that is, you are creating another slab over the mother slab. And since it is a closed self-spray material, water impregnation is almost negligible.